Good morning students. Welcome to your software engineering class. In the previous session, I have discussed about black box testing. Black box testing concerned with the functionality of the software. And in this session, I will discuss about white box testing. White box testing is concerned about the internal code of the software. It checks the code. Okay, so let's start. White box testing is a software testing technique in which internal structure, design and coding of a software are tested to verify flow of input-output and to improve design, usability and security. Means white box testing is a method to check the internal structure, the flow control, the statement of the software. So it checks the internal details of the program. In white box testing, code is visible to tester, so it is also called clear box testing, open box testing, transparent box testing and code based testing or glass box testing. As the programmer or tester can check the internal details of the program, so it is known as clear box or glass box or open box testing. It is a test case design method that uses the control structure of the procedural design to derive test cases. It the most widely utilized unit testing to determine all possible paths within a module, to execute all loops and to test all logical expression. This form of testing concentrated on procedural details. Means through white box testing, the programmer design test cases so that it can check all the statement of the program, all the conditions of the program and all the logical expression of the program, so that the programmer can find any error if exist in the program. And there are many strategies of white box testing, and one white box testing strategy is said to be stronger than another strategy if all types of error detected by the first testing strategy is also detected by second testing strategy, and the second testing strategy additionally detects some more types of error. Means if there are two methods of testing in white box, and the first one, like here the test in B method, it found some error, and in A it found all the error that found in B and some additional error, then A is stronger than B. Okay, and if there are two method and they found some new error and some common error, then the concept is known as complementary strategy. This is the complementary strategy. Means A found some new error and B found some new, and they also have some common error. This is complementary strategy, and this is stronger testing strategy. Then there are different white box testing methodology like statement coverage, branch coverage, condition coverage, path coverage, data flow based testing and mutation testing. In this video class, I will cover statement, branch, condition. Okay, and in next I will cover these three white box testing. So let's start with statement coverage. The statement coverage strategy aims to design test cases so that every statement in a program is executed at least once. Means statement strategy aim to cover all the statement of the program. Means we have to design the test cases in such a way that every statement of the program get executed. The principal idea governing the statement coverage strategy is that unless a statement is executed, there is no way to determine whether an error exists in the statement. Unless a statement is executed, we cannot observe whether it causes failure due to some illegal memory access, wrong result computation, etc. Means if we not execute all the statement, we cannot find out if there exists any error or not. So we have to design test cases so that all the statement of the program get executed. So this is an example to compute GCD. So this is the example to compute GCD. So first statement is while x not equal to y, then if x is greater than y, then x equal to x minus y, else y equal to y minus x, then return x. So for this we have to design test cases that every statement will execute it at least once. Okay, so first of all we execute this statement and this. So for x not equal to y and x equal to y. So the test cases is first x equal to y, x5, y5. x5, y5 can execute 1, then 6. Okay, 1, then 5, then 6. Okay. So next is for x not equal to y means x5, y4. So x5, y4 can execute this one and okay, execute this line and this line, this statement, then also this, then 5 and 6. So 1, 2, 3, 5 and 6. Okay. So x5, y4, 1, 2, 3, 5, 6. Then for x4, y5. So then x4, y5. So x4, y5 means this condition is true. It will executed. Okay. First it executed statement 1. Then it executed 4. Okay. Then 5 and 6. Then 5 and 1, 1, 4, 5, 6. So 1, 4, 5, 6. 1, 2, 4, 5, 6. Okay. So in 2 it check x is greater than y. If true it will execute at 3. If false it executed 4. So it executed 4. So these test cases cover all the path 1, 5, 6, 1, 2, 3, 5, 6 and here 1, 2, 4, 5, 6. So these are the test cases by which we can cover all the statement. Okay. So the test cases are x equal to 5, y equal to 5, s equal to 5, y equal to 4, then x equal to 4, y equal to 4. Means we have to design test cases like that the program, in a program every statement will executed. Okay. Then the next is branch coverage. In the branch coverage based testing strategy, test cases are designed to make each branch condition assume true and false value. Means for every condition we will give true value and false value. Branch testing is also known as edge testing, which is stronger than statement testing. So for the above example, we have designed the test cases. So for while x not equal to y, so we have to design So this is the example for branch coverage. So the test cases of branch coverage is first x equal to 6 and y equal to 6, x equal to 6, y equal to 6 and x equal to 6, y equal to 7. Means this will cover the branch x not equal to y, and if the x equal to y, then this condition, the test cases cover the true and false of statement number 1. Okay. Then the next test case is x 8 y 7, means x greater than y, and this test case is x less than y, means all the branch are covered through these test cases. Okay. So these test cases cover all the branch of the program. Then the next is condition coverage. In this structural testing, test cases are designed to make each component of composite conditional expression assume both true and false value. For example, the conditional expression C1 and C2 or C3. The components C1, C2 and C3 are each made to assume both true and false value. Means for C and C2 false and true value, then or C3 true and false value. All values should be tested in condition coverage. In condition coverage, every condition is tested, and condition coverage is stronger than branch coverage. Branch coverage is stronger than statement coverage. So this is all about the statement coverage, branch coverage and condition coverage. Next class I will discuss about part coverage.